This is a demonstration about how to plot your chromatogram from your GCMS run and how to search mass spectra in your library and printer. Once you have finished your run, click on the icon here at the bottom with enhanced data analysis. Then you get a different screen. Then go to File in the upper left hand corner and select Load Data File and select the file you want to use. Then here you get your chromatogram. Then the first thing you need to do is to integrate your chromatogram. Then go to Chromatogram and click Integrate. Then you see retention times appearing with each peak, but there seem to be a lot. So we go to Integration Results, also under Chromatogram. Click on Integration Results and you get a peak table. There are 32 peaks, which is a little bit too much. So we prefer to have between 15 and 25 peaks. Small peaks are just below 20 million. So we can go again to Chromatogram and then go to MS Signal Integration Parameters. And then we see the initial area reject, which is now set at 10 million. We click on this value, we can change it to 20 million. Click Enter, click OK, click Save Changes. And then we're going to reintegrate the chromatogram. Go to Chromatogram and click Integrate. Now we have fewer peaks. Just to see how many, we click on Integration Results. Now we see 21 peaks, which is perfect. And we click on Print. And again on Print. And then we can click Close. We can also print the chromatogram itself. Then we go to File. Click on Print, the selected window is 2, it should be OK, window 2, OK again, and now we have made a print of the chromatogram. After the integration and printing of your chromatogram, we can now have a look at the mass spectra which are behind each peak. You push down the left mouse button and then you can draw a rectangle and zoom in into a part of the chromatogram. Then you can double click right to get the mass spectrum of each peak. So go to the middle of each peak with your cursor, double click left, and then you see here the mass spectrum which belongs to this peak. Then again, if you go somewhere in the mass spectrum with your cursor and you double click right, you get the mass spectrum which in the library which gives the best fit with your mass spectrum. So this is the mass spectrum of scan 1035 at 5.92 minutes, and this is spectrum 15,387, and that is the peak of Camphain. You can see there are multiple peaks of Camphain in the library. You see a very good resemblance between your spectrum and the library spectrum. But you see this is the quality, so the higher the number, the better the fit between your spectrum and the library spectrum. If you go down a little bit to, for instance, 4Carane, which is a different compound with a fit of 87, you can see it also looks quite similar to your spectrum, but there's an important change here between the fragment at 107 and the 105. So this is definitely not your compound. If you wish, you can plot the most important peaks by clicking on Print. If you don't want to print, you click on Done. If you want to go back to the previous chromatogram, you go somewhere in the chromatogram and you double click left, then you get the entire chromatogram. Then again you can push down the left mouse button, zoom in, and then you can investigate the next peak by double clicking right, and again by double clicking right you get the best spectrum in the library. And this way you can go through the for instance the 10 most important peak of your sample. It's also possible to search for certain peaks. That's in the protocol. It says that you can look for beta Uitersmol, which is a very small peak. Then we go to extract ion chromatograms, and then you can fill in the typical peaks of beta Uitersmol, which is 164, 149, 108 and 59. We then click OK. You get 4 traces here depicting peaks which 164, 149, 108 and 59. All 4 should occur in the mass spectrum of beta Uitersmol. That's what you see over here. And again, if you double click right twice, you can get the spectrum, and this is the library spectrum of beta Uitersmol, giving a fit of 91%. Again, you can click print if you wish. You can also read the retention time over here, 1577. You go to chromatogram and you draw the chromatogram and you integrate again. You can see that 1577 is really a small peak. It has not even been integrated. That is this peak here of beta Uitersmol. So in this way you can hunt for small peaks you are typical of your compound. This ends the demonstration, and you can restart a new injection by going back to the this screen where you have the control over your run and the auto sampler.